All right, welcome to Unit 4, Day 6. We are looking at proofs involving CPCTC. Okay, we will still be using triangle proofs. But we're going to be taking the proofs we've been doing over the last couple lessons and taking it one step further using CPCTC. Remember what this stands for. Corresponding parts of congruent triangles are congruent. All right, remember that. And we can use CPCTC when we are asked to prove that certain parts of triangles are congruent. Okay? But first, before we can use CPCTC, we have to prove the triangles are congruent. All right, we have to prove the triangles are congruent. First, and remember that we can prove triangles are congruent using side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. Then we will prove that another set of parts not used in the proof previously are congruent by CPCTC. So the best way to show you how this is done is just to do an example or two with you. So let's take a look at our first example. All right, in example 1, we're given this diagram. We have two triangles stacked on top of each other like this. We are given segment AB is congruent to segment AD, and segment BC is congruent to segment DC. And we want to prove that angles BCA and angle DCA are congruent angles. And we're going to do that by first proving the triangles are congruent, then using CPCTC to prove that these individual parts are congruent. Okay, so we're going to use this shorter way of writing our proofs. Okay, we will write our statements, and then in parentheses we'll give each reason. And we can just make our list. All right, first of all, we're going to start with the first given statement and mark it as we go. AB is congruent to AD. It's a given pair of congruent sides. And we're given that BC is congruent to DC, another pair of congruent sides. Again, we want to show that the triangles are congruent before I show these angles are congruent. So except for what I was supposed to prove, there is no angle measures talked about. And since they share side AC, we can use that as a pair of congruent sides also, so that creates my third pair of congruent sides by stating AC is congruent to AC by the reflexive property. We can now show side-side-side congruence. So in statement 4, we can say triangle ABC is congruent to triangle ADC. I want to make sure we match up corresponding parts. AB is corresponding to AD, and BC is corresponding to DC. And the reason we've just shown is side-side-side. Now, we're not done with the proof. All that enables me to do now is to say that since these congruent triangles are given this way, their corresponding parts are congruent. Angle BCA and angle DCA are corresponding parts. So they have to be congruent by CPCTC. So that's our final statement, that angle BCA is congruent to angle DCA because of CPCTC. And that finishes the proof. Okay, let's take a look at our next example. Okay, example 2, here's our given statements and our statement that we're required to prove, and the diagram that goes with it. Go ahead and copy this down, pausing the video to give yourself time to do that. And now you should be ready to follow along and complete the proof. Again, we want to use congruent triangles to prove that their parts are congruent. PQ should correspond to RS, okay? And they should be congruent if these two triangles are congruent to one another, so that's what we're going to show first. Okay? The majority of our proof will go to show that the triangles are congruent, and the last statement will be that these parts are congruent because of CPCTC. Okay, so we're going to start off with the first given statement. Now, I need you to remember that parallel lines, PS and QR, should tell us that certain angles are congruent. And what I want you to notice in this diagram is that segment QS can act as a transversal. Okay? So if PS and QR are parallel and QS is a transversal, that creates this Z shape, which you should remember gives us congruent angles here and here because they are alternate interior angles. And so after we say they are parallel, a secondary statement is that angle PSQ is congruent to angle RQS by the alternate interior angles theorem. Okay, so that would be statement 1. That leads us to statement 2. And then we also have that angle QPS and angle RQS, I'm sorry, I wrote that wrong. No, right here, SRQ, sorry about that. That these angles are congruent. And I could just call that angle P is congruent to angle R. Okay, we don't need to use all the letters because there's only one angle at P and one angle at R. So those are congruent angles because it's given. Okay? And so I have congruent angles here and here. I have another pair of congruent angles because of the alternate interior angles theorem. And that's all the given information. But we also know that they share side QS. And so there's a pair of congruent sides. Now notice the congruent sides are not the included sides between the two different angles in each triangle. So I'm not using angle, side, angle, because the side markings would not be between the two angles. I would use angle, angle, side. So that's what I'm going to use to prove the triangles are congruent. So let's start off with our first statement. Segment PS is parallel to segment QR, which is given. But remember, that leads us to another statement, that angle PSQ is congruent to angle RQS because of the alternate interior angles theorem. So there's a pair of congruent angles. And then we have another pair of congruent angles, and I'm just going to write angle P is congruent to angle R because that is given. So there's another pair of congruent angles. And then the congruent sides, QS to QS. By the reflexive property. So there is enough information to show that the triangles are congruent by angle, angle, side. So we can say triangle PQS is congruent to triangle RSQ because of angle, angle, side. which means the corresponding parts PQ and RS must be congruent by CPCTC. So we can say segment PQ is congruent to segment RS because of CPCTC. And that finishes our proof. All right, we're going to try one more example. Okay, take a moment to copy this down. Pause the video if you need to. Okay, make sure you draw this accurately and label it accurately. And I'm going to kind of get you started in this, and then I'm going to have you pause the video and actually try and do most of the proof, and then we will finish it together. So you'll pause the video for part of this and try and complete the proof on your own. I fully understand that you could just wait until the end and copy it all down, and you're welcome to do that if you get stuck and don't understand what you're doing, but I want you to make an attempt to do the parts that I ask you to while you pause the video. It's really going to help you start to do these proofs a lot better. Okay? So first of all, let's take a look at what is given to us and see if we can figure out anything from that. Okay, we have this drawing. We have two triangles, and we're told that X is the midpoint of both of these segments, WY and VZ. So if X is the midpoint, that leads us to a second idea, that we have congruent segments. Okay, if X is the midpoint of WY, that means WX is congruent to XY because of the meaning or definition of midpoint. And if X is the midpoint of VZ, that means VX is congruent to XZ by the same reason. Okay, so there's how we can get two pairs of congruent sides. And then you'll also notice that we have congruent angles here by the vertical angles theorem. Okay, and so we could show that these triangles are congruent by side, angle, side. Okay. So I'm going to go ahead and tell you that this is going to be 6 steps. I'm going to give you the first one. We only have one given statement written, even though it tells me 2 things. Okay, so we're going to say X is the midpoint of WY and VZ because it's given. And then I want you to make these next 2 statements based on the meaning of the word midpoint. And then also the next statement, statement 4, is going to be about congruent angles here by vertical angles, so that we can show that the triangles are congruent in statement 5. So I want you to work to try and finish statements 2 through 5. This should be that the triangles are congruent, and then we'll finish it out. So pause the video and try and do as much of the proof as you can, focusing mainly on getting through step 5. And then I'll show you how to finish it. Okay, if you need any more time, go ahead and pause the video, but this is what we should get. All right, we should get this. After statement 1, that X is the midpoint of these 2 segments, that tells you that WX is congruent to YX by the definition of midpoint, and that VX is congruent to ZX by definition of a midpoint. So there's the 2 pairs of congruent sides. And that this angle, WXV, is congruent to angle YXZ by vertical angles theorem, which means that triangle WXV is congruent to triangle YXZ. And you could have called your triangles by different names. You could have changed these letters as long as your other letters match up. But your reason is side, angle, side. And so once we've shown triangles are congruent, angle W and angle Y are corresponding parts of those 2 triangles. So that means that angle W is congruent to angle Y because of CPCTC. And that finishes the proof. All right, we'll do some more examples in class, but that finishes up our lesson for this video. Make sure you get this watched and written down exactly like I have, and bring it to class ready to go.